In 1912, the British geologist George Barrow mapped a southeast part of the Scottish Highlands. That's what we're looking at on this map here. Now it's beautifully coloured in to show what George Barrow described as metamorphic zones. What we're basically doing is from south to north, we're moving towards some granites. What Barrow reasoned was the temperature rose as we moved in this direction because of granite being a magma at the time of metamorphism. And he defined the metamorphic zones because what he discovered as he walked through this sequence was that there was a particular mineral he called an index mineral that showed up in each of these zones. And those index minerals are what we now call the Barrovian index minerals after Barrow. And we use them to get a first order indication of the temperature of metamorphism. Let me show you how this works. I'll pop that map down. I have the index minerals in front of me here. At low metamorphic temperatures, far away from the granite, we find that clay in a mudstone transforms into chlorite. That's this stuff here, this pale green mineral. If I break off a piece, and we'll take a nice close look at it there. That's chlorite. George Barrow found it in this area down here, that strip down there. He called that the chlorite zone. It was the first time moving up temperature that chlorite was observed. Continuing to move up temperature, that's moving towards the granite, indicating high temperatures, heat, he enters the next zone. The next zone is called the biotite zone. We've got some biotite here. That's this beautiful mineral here, which we can kind of break up into sheets. And let's take a good look at that. See the dark brown color? I'm going to take a tiny piece of it here so I can lay that out in the map there. There we go. So that was our biotite zone. If we continue now, temperature keeps rising. We're moving towards our granite. We have chlorite and biotite in our rock, and then bang, we get a new mineral. That mineral is called garnet. And that's what I've got in this box. I've got lots of them. They're really quite beautiful. They're a slightly reddish coloured mineral. I'll take this one because I think we can see the red colour slightly better. They're kind of dark garnets, these ones. Yeah, maybe you can just about make out that it is a slightly reddish coloured mineral. That's garnet. The first appearance of garnet defined the garnet zone. So let's place that there. We continue up temperature. And our mudstone is now metamorphosed even at higher temperatures. And the next mineral we observe, the next index mineral, is called staurolite. I've got a whole box of them here. And they're kind of distinctive because they're kind of star-shaped. Let's take a look at them over here. If we look at that, do you see that's kind of star-shaped? The brown crystals are crossing each other. We've got another one here. It's a little difficult to get. There we go. There we go. Hopefully you can just about make out that those two crystals crossing each other. Staurolite. Let's pop that into the staurolite zone. Carry on increasing the temperature. The next mineral to form and the next index mineral, we get the first appearance of kyanite. The name comes from the colour, cyan blue. So we have a look at that one, what that one looks like. It's really one of my favourite minerals. It's really, really beautiful. Beautiful blue colour. First appearance of kyanite, we're into the kyanite zone. We'll pop that there. And we've now been through 5 zones: chlorite, biotite, garnet, staurolite, kyanite. And as we're not melting yet, but we're getting to, the rock's getting really hot. And then we get another mineral, the final one appears, and that's called sillimanite. It's this kind of fibrous mineral here. It almost looks like hair matted together. Let's have a close look at it there. Let's see if we do like that. I don't know if you can see there are actually lots of thin fibers pressed together. I'll take that one, it might be even a bit better. That's selimanite. We'll pop that there. So what we're actually observing is by the first appearance of each index minerals, we have an indication of the temperature of metamorphism. We call these the metamorphic zones, and they're used to tell us metamorphic grade. Chlorite grade, biotite grade, garnet grade, staurolite grade, kyanite grade, and selimanite grade. So now if we went away from this particular part of Scotland, which is of course called Glenesque, we would find that if I find myself some kyanite, I can say I'm in the kyanite zone and I already know something about the temperature of metamorphism. Thank you for listening.